This is a blue cup of water, and this is a red cup of water. You take the blue cup, and it's just like any other day. Your life goes on. You take the red cup, your life is over. For many, this is not a choice, but a risk they must take every single day. For others, there's a never-ending stream from the blue cup. So how did we end up in this situation? To answer that question, we need to first understand where our tap water comes from. First up, we've got groundwater. A cool 30% of the fresh water used in the United States comes from here. This type of water is located deep beneath the ground, where it collects in spaces within rocks known as aquifers. The water gets here from the surface, being naturally filtered by the soil and rocks as it seeps its way through. Think of it as an underground cool kids club, where only those that have gone through the security can get into. That's why groundwater tends to be the clean, older brother compared to its sibling, surface water, which covers the remaining 70% of where our fresh water lies. Surface water, as the name hints, is basically any water kicking it above the ground or rubbing elbows with the surface. Think lakes, rivers, or ponds. Now since it's out there in the open, it tends to pick up a bit more stuff. That means we need to give it some extra TLC, tender loving care in the treatment department. And that brings us into our next section, water treatment. Whether we're dealing with sneaky pesticides that made its way into the groundwater, or finding out that Bear Brown's apple juice has made it into the surface water, we need to get it all cleaned up before they hit our cups. The water treatment process begins with meeting the dynamic duo coagulation and fluctuation. You see, all the nasty stuff in our water is typically spread all apart, which makes it difficult to filter out. This is because of their size and their negative charge. Based on the fundamental principle of electricity, like charges repel and opposites attract. So we add chemicals known as coagulants, a bunch of positively charged particles to neutralize all the nasties. Once these particles are neutral, another phenomenon occurs known as van der Waals forces, which causes neutral particles to become attracted to one another, meaning that all the small dirty particles are going to form together to become one big dirty particle and settle to the bottom, which we can then filter out. Finally, disinfection is done by adding elements like chlorine to the water, a process similar to what you find in a swimming pool. Take note that these are the typical steps done to treat water, but depending on your city and country, there may be more or less. Once treated, we need to be able to get it to households safely. In the United States, distribution systems span over 1 million miles or 1.6 million kilometers. That's equivalent to going around Earth's equator 40 times and represents the majority of where the physical infrastructure is spent on. Think of all the roads that connect us to one another. There are underground systems that do the same for our water. As water is pumped through these pipes, it's stored in giant water tanks to make sure that there is always water available. The population of California is 39 million people. Now imagine 20 million all taking a shower at the same time as they get home from work. With such a huge network, it's not surprising that operation and maintenance makes up the majority of the cost. Maintenance is a crucial step, as contamination during water distribution is still a huge problem. As pipes wear out, they can corrode, resulting in toxic materials leaching into the water supply. Take the infamous case of the Flint water crisis as an example. In 2014, the drinking water for the city of Flint, Michigan was contaminated with lead and pneumonia causing bacteria. Corrosion inhibitors are normally added as part of the water treatment process to prevent this from happening, but were cut out as a cost-saving measure. This resulted in over 100,000 residents exposed to high levels of lead, including 12,000 children. Lead poisoning can cause many problems, including a reduction in intellectual functions and increased chances of Alzheimer's disease. It's currently estimated that by 2041, the water systems in the United States require $625 billion of investment to continue providing clean, safe drinking water. That is almost 3/4 of the budget that the country spends on the military. Water distribution stands as the biggest cause of water scarcity around the world. In Africa, 1 in 3 are facing water scarcity, and this number continues to get worse every single year. If you've watched this video up to now, during this time, almost 10 people have unfortunately passed away in Africa due to unsanitary water. You see, 30% of available water lies in the Congo Basin. However, only 10% of the population lives here. The lack of access to water has people walking on average 3.7 miles or 6 kilometers to get water. To give you a perspective, that's 15 laps around a football field. For many, this is something that is done multiple times a day up mountains and through forests. Generally, each trip per person yields 20 liters of water. That's 44 pounds. Your average shower lasts 8 minutes, and each minute uses 8 liters per minute. That means more than 63 liters of water. An average American family uses more than 1,135 liters a day. Now that's a lot of football fields to walk. Africa is not the only place experiencing water shortages. Over 1.6 billion people, a fifth of the world's population, face economic water shortage, where countries lack the necessary infrastructure to provide water in an accessible manner. Another 1.2 billion people live in areas of physical scarcity. While there is enough fresh water globally to meet current demands for the planet's 7.8 billion people, water scarcity arises from the misalignment between when and where people need water and its uneven distribution around the world. So, what options do we have other than continuing to conserve water and use what is only necessary, as well as continuing to raise awareness of the problem and helping out where we can? One of the big topics right now is reusing water. And I mean toilet to tap reuse, or showers to flowers if you prefer. Potable water is treated water that has been tested to be safe for human consumption. The word potable comes from potare, the Latin word which means to drink. In the United States, a typical household has a central water tank system that uses the same water for our sinks, showers, and toilet bowls. This means the same water you drink from the tap is the same water you use to flush your toilet. Other places, like Hong Kong, have adopted a more sustainable approach, where flushing, for example, is done with seawater. Once it is used though, it becomes wastewater, and we follow a whole different set of treatment steps where it can eventually be used for things like agriculture, but never directly back for human consumption. That is, unless you live in Texas, specifically Big Springs and Wichita Falls, two cities of the few worldwide which have adopted the DPR system, direct potable reuse. The system involves reusing treated wastewater as drinking water. The water is still tested and treated like any other, just without the environmental buffer. While this may sound gross to many of us, access to safe drinking water is crucial to every single human and is recognized by the United Nations as a human right. In the case for these Texan cities, it was an easy decision to make as both communities were struggling with dire drought conditions. Many other states are also working on legalizing this process, including Florida, Colorado, and California. So you too may soon see such a system in the very, very near future. And there you have it, my newfound appreciation of tap water. How do you feel about the showers to flower system? Let me know in the comments. And if you enjoyed this video and want to see where Bear Brown ends up next, remember to leave a like and subscribe to the channel.